For example 2, we need to graph and analyze the following exponential equation. We've got a negative, then a 3 to the x plus 2, and then a minus 4 hanging out on the side. So let's take a look at this and let's see if we can determine what we can expect from this graph. First of all, the graph has a base of 3. So this graph is going to behave like not only an exponential, but it's going to behave like y is equal to 3 to the x, or f of x is equal to 3 to the x. If we look at this first part, this negative sign is not included in parentheses. And what this negative sign is going to do is it's going to reflect the graph. And it's going to be a reflection over the x-axis. So that's one thing that we need to be careful of. This plus 2 is right by the x, it's in the exponent position. So this is actually going to be left by 2 units right here. This negative 4 is not in the exponent position. It's going to be a vertical shift. In this case, it's going to be down by 4. To graph this pretty efficiently, what we can do then is we can take what a normal, I would say maybe we'll go y is equal to 3 to the x would look like. So this is not the graph of this equation, but we can go ahead and take a look at this. And this will help us to find some more points. So 0, 1 is going to be a point on this graph. After all, 3 to the 0 power is 1. So 0, 1 is a point. And the next thing we need to do is just divide this whole distance by 3. And so the next point is going to be negative 1, 1/3. And then it's going to get very, very tiny. It won't exactly hit 0, but it'll get real close. So this graph is going to look something like this on the left-hand side of the y-axis. The right-hand side, this 1, 3 to the first power would be 3. And it's going to be 3 up here, so it's going to be 1, 3. All you do is you can just plug in this value 1 into the equation, or if you prefer, you can take this length right here, which is 1, and multiply it by 3. Take this length, which is 3, multiply it by 3, and you would get 9, so that would be a point right up here. So here's what this graph would look like if we were to graph y is equal to 3 to the x. And you can plot that fairly quickly once you know the ins and the outs. The big point is the 0, 1 right here. That's going to be on all of them, no matter what that base is. And then also, just take a look at your base, and that'll tell you what to do with the 1 here. Divide it by 3, then divide this by 3. Or, if you go to the right, meaning in the positive direction, you just multiply that by 3. And you can plot your points fairly easily. Let's apply what we have written down here in green to this graph below. First of all, this point 0, 1 is going to be reflected, and it's going to be shifted as well. So the point 0, 1 would be reflected, and we need to go left by 2 and then down by 4. Also, what you'll notice is that for this one there's going to be a horizontal asymptote at negative 4. So we can actually go ahead and draw that in here. So there's our asymptote. It's not part of the graph, it just helps us a little bit. And then if you take a look, if this shape in purple were just flipped over and shifted a little bit, this next point here is just going to be that 1/3. So we're going to go real close to this, this horizontal asymptote, and then we're going to get a little closer, and so on and so forth. And then if you look to the right of 0, 1, that's our kind of our main point right here, we're going to go right 1 up 3, or up 3 from the horizontal asymptote. So we're going to go right 1 up, or in this case down, I guess, 3. That's what the reflection would do. If we were to plot 9 units up from the asymptote, or in this case 9 units down, we'd be way off the graph. So you can go ahead and just connect them like this. Now that graph will continue to grow in this direction. However, in this direction, we're just going to approach the asymptote and never go, in this case, above it. Now one of the things that we need to do is we need to analyze this thing. So one thing that we know is that there is an asymptote at y is equal to -4. And all that is that's just the vertical shift. It's down 4. Normal y is equal to 3 to the x would be right here at 0. So we're just going to shift everything down by 4. For the domain, we can still pick whatever we'd like to, any real number. So an interval notation that's -infinity to infinity. And for the range now, we have a little bit of a different story. Any value down here will work. Any value, as a matter of fact, lower than -4 will work. So the graph will exist from -infinity up to, but not including, so there's our parenthesis, to -4. Keep in mind we want to write the -infinity first, then the -4 next. So -infinity is a lot lower than -4. Try to use the lower number on the left, the higher number on the right.